Hello, students. So, how are you all? I hope you all are doing good. So, I welcome you all again to the next lecture of this chapter, Motion in Two Dimension. Okay. So, in the last class, what we have done, we have already seen how to define motion with the various physical parameters. Yeah. Or to be precise, circular motion. And we all know circular motion is a type of motion in two dimension. Okay. That is the thing we are learning. Okay, so today what we are going to learn in this lecture, now let's see. We are going to learn two main topics or two new topics you can say, which are related to the circular motion, that are centripetal acceleration and tangential acceleration. So in the last class, we have already defined angular acceleration. That angular acceleration is the rate of change of angular velocity. Rate of change of angular velocity, that is defined as angular acceleration. So suppose if I give you example before going into the main topic, we all have gone to amusement park. Yeah, we all have visited amusement park in our childhood days. So what we do in amusement park, we enjoy some rides. We enjoy some rides, and if you observe, there is some ride which is known as swing ride, in which you sit in this box and it will rotate like this. There are the several number of boxes in that ride, and they kind of rotate. Yeah, they kind of rotate like this. So when you are sitting in that swing ride, what you feel something is pulling you out. Yeah, something is pulling you out actually. Okay, one thing is this. Second case, if you can observe, was the example I was giving you in the last class also. There is some person holding the thread from one end, and through the other end of the thread, a stone has been attached, and it is making the stone to rotate in a circular path. So something is holding this stone, yes or no? Something is holding this stone to move in the circular path. Okay, so one thing is this swing ride, another thing is this stone motion. Yeah, stone motion. Now see another thing. Suppose I am taking a rectangular track. I am taking a rectangular track A, B, C, D. I want to travel in this circular track A, B, C, D with a constant velocity. What I want to do? I want to move in a constant velocity. So what I'll do, the athlete will try to run from A, B, B, C, C, D, and then D, A. What he has to do to move with constant velocity, that at the four corners, suppose at B, C, D, and A, it has to, or he has to suddenly change its direction, yes or no? If he was moving from A to B, then after reaching at B, he has to suddenly change its direction towards C. So during a complete rotation, it has to change its direction 4 times. It has to change its direction 4 times. What about if I make a hexagon in place of a square? What if I make a hexagon? So in this hexagon, the person or athlete has to change its direction at 6 points, 6 corners of the hexagon. Yeah. So that its velocity is constant. Okay. Now the case is that suppose I am making an octagon like this. Okay. I'm making a octagon like this. Now there are 8 times. 8 times a person has to change its direction during a complete rotation. So what you are observing, as far as or as more and more number of sides I'm increasing, more and more times the number of directions should be changed by the athlete. Suppose I am making a circle. So circle is I can say polygon of infinite sides. Yes, infinite sides that is made up of different sides, and each side has a length of point only. Because yeah, it is continuously changing its motion. An athlete has to continuously change its direction at every point. Continuously change its direction at every point. So that change in direction is handled by acceleration. Before going into that name of acceleration, what is velocity? Velocity is something consisting of magnitude plus direction. Yes or no? Velocity is something consisting of magnitude and direction. And I told you, if velocity or magnitude of velocity is constant, if velocity or magnitude of velocity is constant during a circular motion, that type of motion is known as uniform circular motion. So in uniform circular motion, speed, you can say speed is constant. So that is known as uniform circular motion. So if there is change in direction at every point of time, if you observe a circle, if you observe a circle like this is a circle. And if you observe at every point, the direction of velocity is tangential. At every point, the direction of velocity is tangential and it is continuously changing. Okay. So although the magnitude of velocity is not changing in circular motion, but the direction is constantly changing. So if direction is changing, can I say velocity is changing? Yes or no? Yes. Because velocity can be changed by change in magnitude or change in direction or both. So in our case of uniform circular motion, magnitude is not changing, only the direction is changing. So due to that change in direction, velocity is also changing. And you know, if velocity is changing, there is some acceleration involved. There is some acceleration involved. So that acceleration, which is the reason for change in direction of a body, that acceleration, which is responsible for the change in direction of the body or the change in velocity due to change in direction, is termed as centripetal acceleration. Is termed as centripetal acceleration. So centripetal is acceleration is that acceleration which is changing the direction of body. Which is changing the direction of body. So it is only concerned with changing in direction, not with magnitude. So this is known as centripetal acceleration, and for any circular motion, centripetal acceleration will always act towards center. Okay, the acceleration is towards the center, and the force which is producing this centripetal acceleration is known as centripetal force. So the force which is producing this centripetal acceleration is known as centripetal force, and always centripetal acceleration acts towards center, and this is the acceleration which is responsible for changing the direction of a body, not magnitude. So if you can see, this person is throwing a shot put. Yeah, this person is throwing a shot put with his hands. So this shot put is doing a circular motion around this thread. So there is some acceleration acting on this ball or shot put, which is making him to change the direction constantly. Yes or no? Because if the body does not change its direction, then what will happen? Suppose you are moving a thread, or suppose I am taking the example of this shot put only. Suppose suddenly, when the person was revolving this shot put, I suddenly cut this wire. So what will be the direction of motion of this shot put? Shot put will move in a tangential direction. Or I can say the direction of the velocity, because the velocity is always tangential. So you can say the velocity is tangential here. The body will or shot put will continue to move in the tangential direction. So this is the thread which was holding this ball, or which was holding this shot put to move in circular direction or circular motion. So that thread is providing the centripetal force, and due to that centripetal force, centripetal acceleration is acting. So the basic concept of centripetal acceleration is clear, that this is the acceleration. This is the acceleration acting towards the center. So what is the direction? Acts towards the center. So this centripetal acceleration is that acceleration which acts towards the center and which is responsible for changing the direction of any body. And this is also known as radial acceleration, because the direction is radial. When I am saying inward or I am saying towards the center, it is known as radial direction. So that's why centripetal acceleration is also known as radial acceleration. So this is centripetal acceleration, as you can see in this diagram, acting towards the center, and the velocity at any point of the circular motion is tangential to the circle. Okay, so this is the circular path of centripetal acceleration. Now if a body is of mass m, suppose a body of mass m is doing a circular motion in a circle of radius r with a constant velocity v, with a constant linear velocity v, then centripetal acceleration is given by AC, which will be mv square by r. mv square by r, this is the formula for centripetal acceleration, that if any mass m is moving with a linear speed of v in a circular path of radius r, then its centripetal acceleration will be given by mv square by r, or you can say v square by r. This is actually the centripetal force. Mv square by r, and you know that the net force is equals to mass into acceleration. So I can write centripetal force is equals to mass into centripetal acceleration, which will be equals to mv square by r, because this centripetal net force, the centripetal is the net force acting on any body towards the center. So if you take this side, m and n will cancel out, and acceleration will be coming as v square by r. So actually centripetal acceleration is v square by r. Mv square by r is the centripetal force which is acting towards the center. So this formula is very important. Centripetal acceleration. So I think the basic concept of centripetal acceleration is clear. That what does centripetal acceleration do? It changes the direction of the body only. It does not affect the speed. It changes only the direction. Due to that change in direction, velocity changes. Because velocity can be changed by changing the magnitude or changing the direction or changing the both at the same time. I think it's clear? Okay. Now moving on to the next topic, which is tangential acceleration. So if you guys give you example, I'm traveling on a straight road with a bike and I'm constantly increasing my velocity. So this velocity is increasing due to acceleration which is known as tangential acceleration. So suddenly during my motion, a curve path is coming like this. A turn is coming. So at this turn, suppose I'm moving with a constant velocity v. So during this turning path, the acceleration involved is only the acceleration which is required for changing the direction. Yeah, because the magnitude is constant. So only acceleration required is due to the or is because of the change in direction or change in direction of velocity, which will be centripetal acceleration. So whenever there is change in speed, that is due to the tangential acceleration. It is due to the tangential acceleration, and tangential acceleration is always along the direction of speed. And we have already seen the direction of speed is along the tangent. That's why the name is coming as tangential acceleration. So tangential acceleration is responsible for changing the speed. Or changing the speed, or you can say magnitude of a body. Okay, clear? This is speed. So what is the basic difference between centripetal and tangential acceleration? Tangential acceleration changes the magnitude of velocity, that is speed, and centripetal acceleration changes the direction of velocity. Yeah. So magnitude change is given by tangential, which is along the tangent, and centripetal or direction change is given by the centripetal acceleration, which is towards the center. That's why it is known as radial acceleration also. Getting my point? So you can see in this diagram, a ball is speeding up. So a ball is speeding up. So the direction of tangential acceleration is along the direction of velocity or increase in velocity, that will be tangential. This is shown by AT, tangential acceleration. And this AR is giving you the centripetal acceleration, which is always acting towards the center. So whenever a ball is not moving with a constant velocity, if I give you a two case, suppose this is first case of uniform circular motion. Uniform circular motion. So can I say what is uniform circular motion? In which velocity remains constant. V, magnitude of velocity remains constant. So can I say there will be no tangential acceleration in the case of uniform circular motion? Because the magnitude of speed or magnitude of velocity is constant, so the tangential acceleration is zero, because this is the acceleration which was producing change in speed. So if there is no change in speed, there will be no tangential acceleration. So in this case, tangential acceleration is zero in the case of uniform circular motion. And there will only be centripetal acceleration, which is towards the center and changing the direction of body. Now this is the case of uniform circular motion. Now the ball is speeding up. The ball is speeding up. Then what will happen? This is the direction of velocity. This is the direction of increase in velocity, because the body is continuously speeding up. So this is the direction of tangential acceleration again, in the direction of increase in velocity, and tangential to the circular path, and centripetal is towards the center. So the resultant acceleration will be like this. This is the resultant of both the centripetal and tangential acceleration of a body. So now I think you can bifurcate between centripetal and tangential. Centripetal for direction change, tangential for speed change or magnitude change. Okay. Now see if the ball is speeding down. Suppose the ball is speeding down. So suppose the ball is speeding down. So this is the velocity. This is speeding down. So the direction of tangential will be opposite, because it is kind of retardation. So this is the direction of tangential acceleration. Centripetal is again towards the center, and this will be the resultant. This is the case of speeding down. That if the velocity is decreasing in this direction tangentially, then acceleration will be opposite to the decrease in velocity, and again tangential only. This is tangential acceleration in this direct case of speeding down. So I think basic things about these centripetal and tangential acceleration are pretty much clear to you. Okay, done. So now if I give you a diagram like this is a motion. This will be tangential and this will be centripetal. Okay, and now if the car is turning like this, so this will be the tangential and towards the center will be centripetal. So always two types of acceleration acts whenever the body is changing its speed. If the speed is constant, as was in the case of uniform circular motion, then tangential acceleration will be zero. Tangential acceleration will be zero. Now I think the cases are clear. One important thing I want to tell you is equations of motion. We have seen some equations of motion in the motion in one dimension. The same will be available here. But the only thing is that what was the first equation of motion in 1D? I'm comparing it 1D, 2D. In 1D, it was v equals to u plus at. Now, in terms of linear velocity, this is angular velocity here. So, omega is equals to omega naught, that is initial angular velocity. In place of acceleration, here will come angular acceleration alpha into t. What was the second equation motion? Displacement is equals to ut plus half at square. So, in place of displacement, there is angular displacement here theta. In place of initial velocity, here is angular velocity initial. Time is same. Plus half in place of acceleration, angular acceleration t square. What is the third equation of motion? In 1D, it is v square equals to u square plus 2as. So in case of final velocity, there is final angular velocity in angular motion or 2D motion. In place of u square, there will be omega naught square plus in place of acceleration 2a. We will put alpha angular acceleration and in place of displacement as we will put theta. So I think you are easily able to convert these equation of motion for two-dimension motion also or circular motion also. That omega equals to omega naught plus alpha t. Theta is equals to omega naught t plus half alpha t square. And omega square equals to omega naught square plus 2 alpha theta. So these are the basic three equations of motion. Okay. So if I summarize what we have learned is that there are two types of acceleration in a circular motion. One is centripetal acceleration that always acts along the center and that is responsible for changing the direction of a body. Okay. Second one is the tangential acceleration, which is responsible for changing the speed. Speed means magnitude only. So for changing the magnitude of velocity, tangential acceleration is responsible. For changing the direction, centripetal acceleration is responsible. And in a uniform circular motion, tangential acceleration is zero. In a uniform circular motion, tangential acceleration is zero because the speed is constant, or I can say magnitude of velocity is constant. Okay. Now we are observing some questions related to what we have learned. The first question reads as, which of the following statement is false? So he's asking about the false statement. Which of the following statement is false for a particle moving in a circle with constant angular speed? Now see, angular speed is given as constant. So if you see in the last class, we have learned a relation between linear speed and angular speed, v equals to r omega. So if this angular speed is constant, and you know in a circular motion, radius is always constant. So can I say this linear speed will also be constant, yes or no? This was the indirect relation given in the question. That if angular speed omega is constant, and you know for a circular part or a particle moving in a circle, radius is constant for a particular circular path. So if r is constant, omega is constant, can I say this v will also be constant? Because it is the multiplication of r and omega itself. This linear speed is also constant. Now see what is saying. Can I say this is a case of uniform circular motion? If v is constant, speed ka magnitude of speed is constant, then it is said to be uniform circular motion. Yes or no? And you know in uniform circular motion, tangential acceleration is zero because there is no change in magnitude of speed. So can I say tangential acceleration is zero? Okay. So if I talk about this v equals to constant condition, only one acceleration acts towards the center, which is centripetal acceleration. Tangential is zero and only a velocity is there. Only a constant velocity is there, which is always perpendicular to the tangential acceleration or centripetal acceleration at any point. Suppose you are taking this point, magnitude is v, acceleration is towards center AC, and both are perpendicular. So these are the properties indirectly the questioner is saying by giving this line constant angular speed. So that is the way how to infer or how to conclude the hidden things which are given in the question. Okay, so he's asking about false statement. Now read one statement one by one. The velocity vector is tangent to the circle. Yes. This is the velocity vector, always tangential. The acceleration vector is tangent to the circle. This is wrong because there is no tangential component of acceleration present here. Why? Because velocity is constant. So tangential acceleration is constant or zero, sorry. So if tangential acceleration is zero, there is no component of acceleration along the tangent. So this one is false. Now see option C. Acceleration vector points to the center of circle. Yes. The centripetal acceleration is there, which is pointing to the center of the circle. What about D? Velocity and acceleration vector are perpendicular to each other. Yes. So that I have already told you, velocity and centripetal acceleration will be perpendicular to each other at every point of the circle. So the correct answer is, or I can say the false statement is option B, that acceleration vector is tangent, because tangential acceleration is zero in the case of constant speed. Okay. Now next, two bodies of mass 10 kg and 5 kg moving in concentric orbits of r and r such that their periods are the same. Then the ratio between their centripetal acceleration. Suppose two bodies are given. One is 10 kg. Suppose I am taking as a 5 kg and another one is moving 10 kg. Suppose they are moving in different radius. What is the radius given? For 10 kg it is given capital R. This is capital R. And for 5 kg it is given small r. Such that their periods mean time period, which means the time taken to complete one revolution. So time period is same for both the bodies. Okay. Masses are given, radius are given. Then the ratio between their centripetal acceleration. What was centripetal acceleration? It was v square by r. Radius. Yes or no? So can I say, first talk about the 5 kg. So what is the speed of 5 kg? Suppose the time period is t. So can I say the distance covered in one revolution is 2 pi r circumference? Yes, because the radius is r for 5 kg. So the circumference will be 2 pi r distance divided by time, which is time period. So this is velocity of 5 kg mass. Let's say v1. What is the radius? Radius is r only. Now talking about 10 kg mass. 10 kg mass has a velocity v2, which is given by circumference, which is 2 pi r. Yeah. 2 pi r, because the radius is capital R for 10 kg mass. What is the time period? T. It is given in the question that their time periods are same. So we are taking is that T and radius is capital R. So what should be the ratio? The ratio between centripetal acceleration, like I am writing acceleration of 10 kg divided by centripetal acceleration of 5 kg. This will give you V2 square by capital R over V1 square by small r. That is V square by R. Yeah. So we have seen V2. What is V2? 2 pi capital R. So 2 pi capital R over T whole square divided by capital R, and V1 square is 2 pi small r divided by T whole square divided by small r. This will give you 4 pi square R square upon RT divided by 4 pi square small r square divided by small rt. This T and T will get cancelled out. 4 pi square cancel out. From r square, one r will get cancelled out. From small r square, one small r will get cancelled out. So you will get the answer r by r. This is the required ratio of centripetal acceleration between the 10 kg and 5 kg mass. Got it? The explanation was simple. Yeah, direct question. Okay. Now moving into the third question. A wheel has a constant angular acceleration. Now angular acceleration is given, that is represented by alpha, which is constant, which is given as 3 radian per second square. This is given. So time interval is given 4 seconds. So during a certain 4-second time interval, it is given as time interval 4 seconds. It turns to an angle of 120 radian. So 120 radian is basically angular displacement given as 120 radian during time interval of 4 seconds. It is being given that assuming that at t equals to 0 means initial condition angular speed is 3 radian per second. So basically initial angular velocity is given at time t equals to 0, which is 3 radian per second. What the question asking? Calculate angular speed at the start of this 4-second interval. So means it is requiring you to find the angular velocity at time t equals to 4 seconds. Yes or no? It is requiring you to find the angular velocity at t equals to 4 seconds. So we are given these quantities. Can I use this equation omega equals to omega naught plus alpha t? We have already learned how to write equations of motion for circular motion. So I have to find omega. Omega naught is given as 3. alpha is given as 3 and time interval is given as 4 seconds. So it will be 3 plus 12, which will give you 15 radian per second. 15 radian per second. So that is the angular velocity at the start of 4 seconds. At the start of 4 seconds, or you can say 4 second interval. Basically, it is asking 4 second interval. So we have misconceived the question. Actually, angular speed being asked at the start of the 4 second interval. So basically, it is saying when you are traveling from 1 to 3 second and 3 to 4 second. Okay, so he is asking for at this time interval 3 to 4 seconds. Okay, he is asking for the 3 to 4 seconds. So at the start of 4 second means at the completion of 3 seconds. At the start of 4 second means at the completion of 3 seconds. So I'll write the value of time here 3. In place of 4, I'll write the value of 3 because you have to find the angular velocity or angular speed at the start of 4 seconds. At the start of 4 seconds means at the completion of 3 seconds. So we'll requiring the time 3 seconds. The answer will be 3 plus 9, which will give you 12. The correct answer will be 12. At the start of 4 seconds means at the end of 3 seconds. So we'll write time as 3 seconds. So 3 into 3 will give you 9. 3 plus 9 will give you 12 radian per second. This will be the correct answer at the start of 4 second interval. Okay. So I hope everything is clear what we have learned. We have learned two simple concepts or yet important ones. Yeah. Yet important ones. Centripetal acceleration as well as tangential acceleration. And I have already given you summary about these topics. Okay. So I hope everything we have studied in this chapter or in this lecture is clear to you. Thumbs up, guys. Okay. So in case of any doubt, what you can do, you can refer to the Ask IITians website. There is a doubt removal forum or doubt forum present on the Ask IITians website itself, in which you can post your doubts and that doubts will be resolved by the experts. Okay. So this will be the end of this lecture. We are going to end this lecture. So stay safe and enjoy. Thank you so much. Bye-bye.